So let's take a look at 1A. So we want to find the domain, range, intervals of increasing and decreasing. So what would our domain be here? What's our smallest x value?
-5.
-5. Do I put a bracket or parentheses?
Bracket.
A bracket. What's our largest?
6.
6. Do we have anywhere that it stops in the middle?
1.
But 1's included here, so do I need a gap in my domain?
No.
No. So it's just from -5 to 6. And 6 has a bracket also, since it's a closed circle.
So even though they're two separate lines, it's one thing?
Right. Even though there's two separate lines, we have a value for x everywhere here from -5 to 6, so we don't have to stop our domain. So it's continuous. Even though we jump here, 1 is still included here, and then it picks up again down here.
But how come sometimes you have like two lines?
That would be if we had like a gap, like if I had a line here and a line here, I have a gap from here to here. So I would need that gap in my domain.
Okay.
Which I'll do the one right below it, C, because you'll see there that there's a gap in the domain. So that's domain. Our range, what's our smallest y value?
-4.
-4. Do I have a parentheses or bracket?
Parentheses.
Parentheses, because I have a hole. And then what's my largest value? 16.
But that's closed, right?
Closed circle, so it's a bracket. So if the -5 had an arrow, it would be -infinity to 6, yeah.
And then
And -infinity would have a parenthesis, because infinities always have parentheses.
16 would be infinity, right? At an arrow, though, not negative.
Oh yeah, the range would also change too, so this would go to infinity, since it goes like up forever. So this would be infinity here. But yeah, that's if it had an arrow. So if it had an arrow, it would be different. Let's look at increasing. Where am I increasing?
From 1 to 6.
Awesome, from 1 to 6. So increasing, decreasing, and constant are just my x values. Where am I decreasing?
-5 to 1.
-5 to 1.
Does it matter if we put brackets or parentheses for these?
Increasing, decreasing, and constant are always, always, always parentheses.
Okay.
Am I constant anywhere here? Nope. So constant, I would put none. Or NA, or...
Can you just not write anything?
No, you have to write something. So just write none, no, something like that if there's no constant. Or if it's not increasing anywhere, right? None, no, anything like that. All right, let's take a look at C. We're going to do the domain for this one.
Oh, so this one you're gonna have 2, right? You're in the opposite of it.
Yep, this one we have 2 because we have a gap. So what's my smallest x value? -infinity. Where does my graph stop? -1. So I have a bracket or parentheses there? Parentheses, because I have that open circle. And then where does my graph pick up again? +1. And then where does it end? Infinity.
Why can't it just be -infinity? Why is it 2?
Because I have this gap here where my graph doesn't have anything going on. There's no x values from -1 to 1. So I need that gap in my domain. All right, next page. All right, let's do the range. What would my range be? 0, parentheses or bracket?
Isn't there 2?
Parentheses, 0 to infinity. Because I'm looking at my smallest y value, so what's my smallest y value? 0. My graph starts at 0. It's a parentheses because it's an open circle. And then my graph goes up forever.
Okay, so now
So it's infinity.
How would you know when range?
So let's say this one started here at 2. My graph would still my range would still start at 0 because this one does. So I'm still have y values. You have to think about it as a graph of a whole. These are just 2 pieces of the whole graph. So since this one started at 0, my range starts at 0 for this whole thing. And then like it goes up, so it goes up to infinity. So just because there's two lines doesn't mean you're going to have two domains and two ranges. All right, so going back to 1a. Let me erase this. So the domain is all of my x values on the graph. So I'm going to start at the left, because you always start at the smallest x value, go to the largest x value. So my graph starts when x is -5. So -5 is where it starts. It's a closed circle, so I put a bracket. Now I just keep walking all the way along the x-axis here. I see that my graph stops at 1 here, but it picks up again down here. So I don't have a gap in the x values, even though there's a gap in the graph. My x values still continue. So it stops at 1, but it picks up right after 1 here. So I don't need to show that gap because it continues. I don't have a gap from 1 and then it picks up at 1. So there's no gap in the x values.
In the second one, because like they're going in opposite directions.
There's a gap in this one because the graph stops at the x value here and picks up again here.
Oh.
I understand what you mean now by the gap.
Yeah. If it was like one x value on top of the other, so like if this one went this way and it was one on top of the other, it would be -infinity to infinity because I don't have a gap in the x values. So for C, so it would be decreasing. So you start at the left. Think about it as like if you're a person walking from left to right. I'm walking downhill here, so I'm decreasing until I get to, I think this was 1, -1. So I'm decreasing from -infinity because it has the arrow, so -infinity to -1. And then once I pick back up again here, I'm walking uphill, so then I would be increasing from +1 to infinity. So increasing, decreasing, and constant are always just the x values on your graph. So even though this is going up, it still starts at -infinity because it's pointing to the left, because we're looking at the x values. We don't care whether it's pointing up or down. So let's look at 2b. So 2b, what should I plug in first? -1. So I'm going to start by plugging in -1. So I have 3 minus -1, which is 4. So I plugged in -1 for x and got 4. Be careful with what you plug in and the math that you're doing. That was probably like the most common mistakes on the piecewise graphs, was that people made silly mistakes in the math, or they like flipped the x and y values. So just be careful. You're plugging in an x value, so that's your x, and then the other one's your y. So we go to the left one and up to -4, to +4. Do I have an open or closed circle? Closed circle. Because it is less than or equal to, so that makes it a closed circle. What else should I plug in for my first piece?
0.
I can plug in 0. Anything less, is 0 less than -1? -2. It has to be less than -1. Again, be careful. People made that mistake on the quiz. So -2. So this would be 5.
When you have like 2 less than or equal to, like, you know how you have 3 terms?
Mm-hmm.
That's whenever there's 2 points and it's not like an infinity line.
Right. So you won't have an arrow if it had like from, like let's say it had x is less than or equal to 2 and greater than or equal to -2, something like this.
How do you know what? Oh, sorry.
You plug in -2, you plug in 2, and you're gonna have you would have 2 closed circles here in between
And then for the ones that only have 1, that's
when it has an arrow.
Yeah.
Yeah.
How do you know what shape you're gonna get? Like with the.
Depends on what type of graph you have. So for this one, what shape are we gonna get? Linear, because it's just an x. There's nothing happening to that x. What about for this one? What type of shape? Like a parabola shape, because it's x squared. Or it could be like this, depending on whether your x is positive or negative. But you'll have that U shape. All right, let's put our second point. So I plugged in -2 and got 5. So I go to the left 2, up 5. Since this is linear, I'm going to connect it with a straight line. So that's my first piece. Now let's look at the second one. What should I plug in first? 1. So I have x squared, so 1 squared plus 1 would be 2. So I plugged in 1 and got 2. Do I have an open or closed circle?
Open.
Open circle. So go to the right 1, up 2, open circle. What else should I plug in?
2.
I can plug in 2. So 2 squared plus 1 would be
5.
5. So I plugged in 2 and got 5. So I go to the right 2, up 5.
Wait, what?
1, 2,
Oh.
3, 4, 5. There's my next point. Do I have a straight line connecting these dots? No. So I'm going to plug in another point just so I can see what my curve is doing. So I can plug in 3. 3 squared plus 1 would be 10. So I plugged in 3 and got 10. So that I go to the right 3, up 10, which is off the graph here. So I'm going to have a curve going this way.
And that's fine.
Yeah.
But then you say it has to be like a.
Yeah.
So you get.
Well, like this graph, the other part that you can't see goes this way. Like this. So like if I was doing less than 1, I have to show that curve to show here. This curve is kind of like, it kind of cuts the curvy part off, so it's still like that though. Because it's just like the right side of 1, which is kind of not that curved. So just plug in your points and see what your graph's going to do. If I plugged in 4, I'm going to get 17, which is all the way up there. So I know it shoots up pretty quickly.
It's not like linear, but it's like kind of like.
It's a little curve. Yes. Let me erase the pink part here.
When I'm doing it, I like don't do when I like for x plus 5, like my slope is 1/.
So, for the first piece, I always start by plugging in the x value here. So I'm going to plug in -4. So I have -4 plus 5, which would be 1. So my first point's -4, 1. Do I have an open or closed circle here? Closed. So I go to the left to -4 and up 1. Closed circle. Next, I can plug in anything that is less than -4.
-5.
So let's plug in -5. -5 plus 5 is 0. So I plugged in -5 and got 0. So I go to my graph, go to the left to -5, stay at 0. Is this linear?
Yes.
Yep, so I just connect the 2 dots with a line. For my next piece, what should I plug in first?
-4.
-4. So I have 3 times -4 minus 4. 3 times -4 would be -12, minus 4 is -16. So I plugged in -4 and got -16. So go to the left to -4, down to -16. It's off my graph, but it's okay. And is it an open or closed circle? Open. Next, what should I plug in?
-3.
I can plug in -3. I'm going to plug in 0 because it's less work. So any number that's greater than -4, so 0. So 3 times 0 minus 4 would give me -4. So I plugged in 0, got -4. I'm going to stay at 0, go down to -4 here. And then I just connect my 2 dots because I know that it's linear. Because it's just an x.
Instead of just having it off the graph, like for the -4 coming -16, why don't you just plug in 1?
Well, because I had to plug in -4 first.
You have to plug in the number that's there.
Yeah, because you want to see where it stops. So these numbers you have to plug in first because you have to have that point on your graph. Because that's where your open or closed circle is going to be. We have to determine if the function is odd, even, or neither. So a couple ways we could do this. We could either plug in a number and its opposite, or we could plug in -x and do it algebraically like that. I think plugging in a number is easier, so we can do that. So I'm going to plug in f of 2 and f of -2. If I get the same answer, is it going to be even, odd, or neither?
Either.
Same as even. What if I get opposite answers?
I don't know which number to plug in, like for like the.
You can plug in any number and its opposite that's greater than 1. So 0 won't work and 1 won't work. But any number greater than that. So I always plug in 2 because it's like the easiest one to work with, especially if you're cubing it or something. So you're working with smaller numbers. But as we'll see in number C, in part C, 2 might not be the best option, but I'll do that one. So we'll see what we can plug in. And then if your answers are neither, opposite, or the same, it would be neither. So I have 2 minus 7 times 2, which would be 2 minus 14. 2 minus 14 is negative 12. So let's see if I get the same answer or opposite answers. So next I have 2 minus 7 times negative 2. What's negative 7 times negative 2?
14.
Positive 14. So 2 plus 14 is 16.
So it's either.
Neither. All right, let's look at B. So what do you want to plug in here? You want to plug in 4? All right.
Plug in 4 for C. Oh.
All right. What is raining? All right. So we're plugging in 2 and negative 2. So we have negative 2 squared minus 2. Negative 2 squared would be 4, but we have to make it negative because that negative's on the outside. So be careful when you're plugging in 2. It's just the 2 that's squared, but that negative is on the outside. So we have negative 4 minus 2, which is
You do the exponent first.
negative 6. Do the exponent first. PEMDAS. Parentheses exponents. All right, so we get negative 6. Let's plug in negative 2 now. So negative 2 squared minus 2. Do the exponent first. So negative 2 squared is positive 4, but that negative on the outside makes it a negative 4. And negative 4 minus 2, negative 6. So it is even. All right, C.
Oh, you wanna plug in the 4 so you can like cancel out the 3 like cancel out that 3?
You think I should plug in 4?
Well, that's what you said. I don't know why, but
I would say positive 10. So just gonna
Can I, what's the cube root of 9? But you would plug in 3 and you'd get 3 minus 1. What's the cubed root of 3?
27. Wait,
Put in
no, that's not.
nine.
No.
You can get
Sorry.
it.
Sorry. I don't forget what I said.
9 would be the best option because 9 minus 1 gives you 8, and 8 is a perfect cube. So I'm going to plug in 9 and negative 9.
You were wrong.
Yeah, I was wrong.
All right, so we have the cubed root of 9 minus 1. So the cubed root of 8 is what? 2. Because 8 breaks down into 2 times 2 times 2. Circle groups of 3. 2 comes out. So 2. Next, let's plug in 9. We have the cubed root of negative 9 minus 1. What's negative 9 minus 1? Negative 10. These are not the same thing, so this is neither.
I mean, if you use 4, you would.
So 4 is our combinations. We just find f plus g, f minus g, f times g, and f divided by g. So when we add them, we just take f and add g. So 7x minus 6 plus our g of x function, which is 4 minus x. Simplify where you can. So I'm going to combine my like terms
Where do you get the 4?
here.
Oh, I understand.
So 7x minus x would be 6x, and negative 6 plus 4 would be negative 2. So that would be my f plus g of x. All right, next let's find f minus g. So I have 7x minus 6 minus my g of x function. So I'm subtracting the entire g of x. So be careful here when you're subtracting. You have to make sure you distribute the negative. So distribute, distribute. So I have 7x minus 6 minus 4 plus x. So since I'm subtracting g, that whole function, I have to distribute the negative to everything inside of it. Combine my like terms. So here I have 8x minus 10. So this is my f minus g of x. And then next I want to find f minus g of 0. So what do I need to do? Plug in the 0. So 8 times 0 minus 10 would give me what? Negative 10. Next I have f times g of x. So that would be 7x minus 6 times 4 minus x. How do I simplify?
No, not FOIL. Oh, FOIL, okay.
FOIL. So 7x times 4? 28x. 7x times negative x? Negative 7x squared. Negative 6 times 4? Negative 24. Negative 6 times negative x? Positive 6x. Awesome. Negative 7x squared plus 34x minus 24. So just combine your like terms and put it in standard form, so make sure that x squared comes first. So that is my f times g of x. Lastly, I want to find f over g of x.
Are we gonna have a restriction for this one?
Let's find out. Are we?
Yes.
Can't be.
And if we have a restriction, we need to.
I know there's a restriction.
Well, let's see.
X is gonna be denominator.
All right, what can x not be?
4.
Awesome. X can't be 4, and why?
Because that would make our denominator 0.
Because we can't have 0 in the denominator. So our entire answer here is this whole thing. You have to state your restriction. Can't have 0 in the denominator.
Oh, you don't need to do the whole like finding what domain.
That would be if it asked us for the domain. But here we just have to say x cannot be 4.
Wait, why the 4? Why is the x can't be 4?
Because I can't have 0 in my denominator here. The denominator cannot be 0. So I would solve for x, add x to both sides. 4 cannot be x, which is that.
And if you needed to find the domain, it would tell you, right?
Yeah. But here, whenever you're dividing, you just make sure that you have to say x cannot be 4. So even though it doesn't ask us for the domain of this one, we still have to state that restriction. All right, let's do number 5. This one will ask us for the domain, so we'll have to find it there. First thing we want to do is add our two functions. So x squared plus 3 plus the square root of 7 minus x.
That's it, right?
That's it. Can't simplify, can't combine any like terms, so that's it. Next, I want to plug in 3. So then I have 3 squared plus 3 plus 7 minus 3.
9 plus
So 3 squared is 9, plus 3
plus square root of 4.
plus square root of 4. 9 plus 3 would be 12. And what's the square root of 4?
2.
So this would be 14. All right, next let's find f minus g.
Wait, but you don't have to do anything for that one?
Nope.
F plus g, x. There's a
We will when it asks us for the domain. So f minus g would be x squared plus 3 minus our g of x, so minus square root 7 minus x.
That's it, and
And that's it. Next one we multiply. So this would be x squared plus 3 times square root 7 minus x.
How do we just leave it like that?
Leave it like that. And then the last one we're dividing. So this would be x squared plus 3 divided by square root 7 minus x.
Are we gonna put something like this in the quiz? Cause I want to.
Log by the square root of 7.
Multiply the top and the bottom by 7 minus square root of 7 minus x. So I'm rationalizing because I can't have a square root in the denominator. So the top becomes x squared plus 3 times square root 7 minus x. And then what would the bottom be?
7 minus x.
Just 7 minus x. And x cannot be 7.
How does the square root of 7 minus x times square root of 7 minus x cancel out the square root?
Because that's like if I had square root 4 times square root 4. It would be square root 16, but it would just be the square root of 4 times 4, so I have a pair of 4s, so that comes out. So here I have a pair of 7 minus x's, so it comes out. So when you multiply the square root times the same thing, the square roots cancel. Because it's like saying square root of 7 minus x squared, because I have 2 of them, right? So the square root and the squared cancel. All right, so now I want to find the domain of this here. I just found f over g of x, so now I want to find the domain of it. When you're finding the domain of a combination, you want to find the domain of f, the domain of g, and the domain of your function that you just found, f of g of x. F over g of x, sorry. So
We have to find
looking,
the domain of all three.
we have to find the domain of all three, and it's going to be what overlaps. So if I had my number line here, it's going to be what overlaps between those three. So looking at f over g, let's do f first. So looking at just f, my function here, is there anything I can't plug in for x?
It's all real numbers.
It's all real numbers. So on my number line, that would be all real numbers from negative infinity to infinity. I'm going to label my number line here too. Just so you can see. All right, let's look at G. What can I not plug into G?
7.
So let's see.
Anything on
I need my denominator, or not my denominator, I need what's under the square root to be greater than or equal to 0.
Anything.
it seems to, I can't think of anything.
Well, let's solve, right? We'll solve this inequality. Add x to both sides. So 7 has to be greater than or equal to x. So in other words, x is less than or equal to 7. So x has to be some number less than or equal to 7. If I plugged in 8 here, what do I get?
-1.
-1. Can't have a negative, so that doesn't work. So x can be anything less than or equal to 7. So going back to my number line. So x can be anything less than or equal to 7. So it's this way here.
So then it would be what? 7, or negative infinity to 7?
But I'm not done yet.
Oh.
F of g of x, our function that we just found here, f over g of x. What did we say x cannot be?
-7.
X cannot be 7 because I can't get 0 in the denominator. So my domain here was x cannot be 7. So that would make this a whole at 7. But it could be anything else. So where do all three lines overlap? So starting at the smallest number, because my domain starts at the smallest, goes to the largest. Do I put a parentheses or a bracket at 7? Parentheses, because I cannot include 7 because my domain here for f over g cannot include 7. So it'd be negative infinity to 7 with parentheses. Let's do another one. We can do our composition functions here. So f of g, g of f. So for f of g, we take g and plug it into f. So this is going to be the cubed root of x cubed plus 1 minus 1. So I took my whole g of x and plugged it into f of x. What can I simplify?
1.
I can simplify the ones, so the ones cancel, because plus 1 minus 1 would just be 0. So I have the cubed root of x cubed. That cancels each other out, so that would just be x. So f of g of x is x. Let's find g of f of x. So now I'm taking f of x and plugging it into my x of g of x. So I have the cubed root of x minus 1 cubed plus 1.
Would that cancel out?
These cancel. The cubed root cubed cancels. So I have x minus 1 plus 1. 1's cancel. So then I'm just left with x.
Now for C, we just plug in 0 as x, right?
So we plug in 0 into our f of g of x, which we said was x.
0.
So if I plugged in 0, that would just be 0.
So these are inverses?
They are inverses of each other. Yep, because we got the same thing for f of g and g of f. So let's look at 7. So first I want to find f of g. So I'm going to take g, plug it into f. So I have 1 over x cubed. I have to cube the top and cube the bottom. So this would be 1 over x cubed. So that's my f of g. For g of f, I take f, plug it into the x in my g. So that would be 1 over x cubed. Are these inverses of each other?
They're the same,
All right.
so assuming no solution, then we just put in 0.
So, yep, f of g of 0 would be 1 over 0, so no solution. Next, let's find the domain of f of g of x. So when you find the domain of a combination, you want to check the domain of the input, so g of x, and you want to check the domain of f of g of x. So looking at g of x, what can g of x not be? What can I not plug in for x in my g?
0.
0.
Can't plug in 0, so x cannot be 0, my g of x function. For f of g of x, what can x not be? So that's this one here.
0.
X cannot be 0. So what do you think my domain of f of g of x is?
Parentheses 0, comma infinity.
Yeah.
Anything else? So that's all the positive numbers there.
Oh,
But
negative infinity 0.
negative infinity to 0, and then 0 to infinity.
So this is one that you would need a u at that.
You would need a u. All right. One more thing that I wanted to point out with the composition function, so like number 6 and 7, we'll look at number 7, so 7a. If it asked us to plug in a number, it could say f of g, f of g of 2. So it could be written like this. Or it could be written like f of g of 2, where it asks you to plug in 2 into your x's. So these are the same thing. It could be written either way. So just don't be surprised if you see it written like this, even though it was written like this in the review. So rate of change is slope. Remember what our slope formula is?
Y goes down.
No, slope formula. How do you find m?
y2 minus y1 over x2 minus x1.
y2 minus y1 over x2 minus x1. So it gives us an x1 and an x2, but we have to find our y1 and our y2. How can I find y1? You said that with so much confidence. Plug it in, yes. So you take what it gives you for x1. So x1 is -2. Plug that into your x. So I have 5. Of course, my pencil's not going to work now. 5 times -2 to the 4th power minus 2 times -2 plus 3. -2 to the 4th power is what? 16. 16 times 5. 80. Plus 4 plus 3. 87. Next, I want to find y2. So when x is 1, I'm going to plug that in now. So 5 times 1 to the 4th power minus 2 times 1 plus 3. 1 to the...
Both.
Yeah, you have to plug in both because you have to find your y1 and your y2.
6. The answer says
5 minus 2 plus 3, so that would be 6. So now we just plug it into our slope formula. So I have y2 would be 6 minus y1, 87, over x2, 1 minus x1, which is -2. 6 minus 87,
80,
negative 81, over 1 minus -2, 3.
So
Can I simplify?
-27.
-27 is our rate of change. So it's the same thing as slope. You're using the slope formula. You just have to plug in to find your y values. So how do I find the inverse? Switch my x to be y and my y to be x. So this will be x is equal to the square root of 9 minus y squared.
Square them.
Square both sides. So my goal is to solve for y. I need it to be y equals. So that cancels. I get x squared is equal to 9 minus y squared.
-1.
Minus 9.
Yeah, that's not.
So I can subtract 9 on both sides. So x squared minus 9 is equal to -y squared. Divide both sides by -1. You need water? Okay. So -x squared plus 9 is equal to y squared.
Square root of both.
Take the square root of both sides. So I get the square root of -x squared plus 9. And then this would be my inverse is equal to. So make sure you put that inverse there, that -1 on it. So you could either say f -1 of x or y -1. Either way works. But you just need to name it as the inverse.
When you have like a fraction of it, say like you have like b for example.
Right, yeah. Because that we only care about the top. So yeah, the fraction is one exception to this. Because you're like dividing by an x, so you're kind of taking out an x. And then also another exception to this, let's say if I had x squared is equal to 0, take the square root of both sides. What's the square root of 0? So x is equal to 0, but this is technically like you get 2 zeros here because I had x squared is equal to 0, so there's like 2, but you only need to list 1. So that would just be another exception to this rule. All right, let's look at E.
Greatest common factor.
Take out the greatest common factor. What's my greatest common factor? 2x. So I'm dividing everything by 2x. So what am I left with?
X squared plus 3x minus 28.
X squared plus 3x minus 28.
Well, you can take, be like x plus 7, x minus 4.
Awesome. From here, I factor my trinomial in the parentheses. That 2x just stays outside, hangs along for the ride. 2 factors of negative 28 that add to positive 3. Gia?
7 and 4, positive 7, negative 4.
7 and negative 4, so that 2x stays out front. And then I have x plus 7 and x minus 4.
So then x is 0, x is negative 7.
You are way too fast.
Sorry.
Split each one of these into its own equation. So 2x is equal to 0, x plus 7 is equal to 0, x minus 4 is equal to 0, and then just solve each one for x. So the first one, divide both sides by 2, x is equal to 0. Next one, subtract 7 on both sides, x is equal to negative 7. And then the last one, you add 4 on both sides, x is equal to 4. So these are my 3 answers here, which makes sense because I started with x cubed, so I get 3 answers. All right, I wanted to do one additional problem that's not on here, and then after that I'll open it up to see if you guys have any other questions. But, so a question that came from, I think it was like 1.3, but we had on the quiz, if I had 2 points, so let's say I had negative 7, 3, and 4, negative 5. So 2 points on one line, and I want to find a line that is perpendicular to this one, and it goes through the points 1, 2. Where do I start?
What's that one?
I want to find the slope
Yeah, and then put it.
of my first line. So I need y2 minus y1, negative 5 minus 3 over 4 minus negative 7, so 4 plus 7. This would give me negative 8 over 11. So this is my slope of this line, but what's the slope of a line perpendicular to that? The opposite reciprocal, which would be 11 over 8. I put it into what?
The y minus y1.
Equals m times f minus x.
Awesome. So I'm going to put it into point slope form. I'm going to use my new point and my new slope. So I have y minus y1 is equal to m times x minus x1. And then I would just need to distribute, add 2 to both sides, put it into my y is equal to mx plus b form.